That's Sam I am, that's Sam I am. I do not like that Sam I am. Green eggs and ham? I do not like them, Sam I am. I do not like green eggs and ham. Would you like them here or there? I would not like them here or there. I would not like them anywhere. I do not like green eggs and ham. I do not like them, Sam I am. Our lesson today kind of reminded me of green eggs and ham because we are going to start representing our proportional relationships in a table, on a graph, with an equation, in a house, with a mouse, here or there, anywhere. Would you eat them in a box? Would you eat them with a fox? Not in a box, not with a fox, not in a house, not with a mouse. I would not eat them here or there. I would not eat them anywhere. We are going to be representing our proportional relationships all different kinds of ways. In your packets, you have this page, and let's see if we can do some decoding for you. Math is kind of connected, and we can represent our situations in different ways. We've talked about this a little bit before. What we are going to do with our proportional relationship is show how they work or in a table or on a graph or with an equation. And one of the things you will need to be able to do is tell if given a table or a graph or an equation, if it is proportional. If you're given a table, the way to tell if it's a proportional relationship is to look at the ratios. If they're the same, then it would be a proportional relationship. On a graph, you're going to have to look at a line. It's a linear relationship, and the line must go through the origin. If it's a line that does not go through the origin, that is not proportional. Or if it's any other kind of graph, such as a parabola, that's not proportional either. In an equation, what you're looking for is for the equation to be of the form y equals kx. And what that means is you can't have anything else. So it cannot be y equals k over x. It could be x over k, because then that's just 1 over k times x. But it can't be k over x. It can't be y equals kx plus 17. Those are not, in fact, proportional relationships. Let's take a look at how this is used in our problems below. Tell if the table shows a proportional relationship. If yes, state the constant of proportionality. Match each sketch with the appropriate graph, and write the equation to represent the situation. So for each of those tables, that's what we're going to do. Likewise, the problem could have just given you a situation in words and asked you to construct a table and a graph and an equation. The first thing, to tell if the table shows a proportional relationship, we need to calculate the ratios. I can either do the snowfall over the trucks, or the trucks over the snowfall. But the trucks over the snowfall is a better measure because in the long run that is going to be my constant of proportionality, and it is also going to be the slope of the line, and it's going to help us to write the equation, and you'll see what I mean. But if they just asked you for the ratio, it doesn't matter which way you do it. So this is technically like our x variable, and this is technically like our y variable. The ratio, 15 over 6, we want to know if that's going to be the same as 20 over 8. Is that the same? Is that the same as 30 over 12? And is that the same as 45 over 18? If we reduce each of those, we will see that in fact they are all the same ratio, and that is 5 over 2. So since we have the same ratio, we know the answer to A is yes. They are in fact proportional relationships. For B, the constant of proportionality, that's what I just did. I figured out what I need to multiply x by to get y. For C, I'm going to hold off for a minute. I'm going to do all three of these, and then we'll have a better idea of which graph matches with which table. To represent the situation, remember, it has to be y equals kx. Well, k is, in fact, my constant of proportionality. So that's going to be y equals 5/2 x. And that is why I did the y over x instead of x over y. Let's look at question 2. So I want to know if the ratios are all the same. So is 4 over 2 the same as 16 over 4? Well, already I see that that fails, and that is definitely not the same as 49 over 7. So none of these are the same. If in fact I look at this table, I can determine what the relationship is, and so should you. So my answer to A in question 2 is going to be no. So then B is an irrelevant question. I don't need to do it. I still need to do C, which we'll come back to. And D, you should have an idea in your head. We like to represent Y in terms of X. So how do I get Y from X? Should be Y equals X squared. Let's look at the last table here. Is 21 over 6 the same as 28 over 8? And is that the same as 35 over 10? And is that the same as 49 over 14? Yes, they are all equal to 7 over 2. And you do need to check every one in the table because they might throw you a curveball and just have that one be off. So make sure to check all of them. So my answer to A then is going to be yes. The constant of proportionality is what I just figured. And we'll check out the graphs in a moment. And so for D, you should already have that written down. Y equals KX. And so that is 7 halves X. We look at each of the graphs that are shown. We need to be able to match those up with each of our scenarios up above. So one of them obviously stands out. That is, if I call these graphs A, B, and C, A stands out because it's a curve, and we know in fact that that is not a proportional relationship. So that has to go with question 2. Now, if I look at the other two, it's kind of hard to tell on these graphs. They sort of look like they're the same, but one is slightly steeper. And the way I can tell that is if I kind of go up here, every time I go up here one, how many places do I move over? Or how many places do these points match up? And if you look at this, one of them is going to match up with 7 over 2, and one of them is going to match up with 5 over 2. So here's 2. For my X, which one matches up with 7 and which one matches up with 5? This kind of looks like it matches up with the 5. If this were on graph paper, it would be easier to tell, and usually you're going to be given a graph on graph paper. So this one looks like it's 5 halves, and this one looks like it's 7 halves. So this is going to go with, C is going to go with 3, B is going to go with 1. On the next page, there's just some examples there. So you should really pause here and after what you've just heard and tell me what you think about the first 9 questions. So this has the +4, which makes it not proportional. That means no. This one's fine. So this one's going to be no. This is fine. It's yes. The third one has the -6. So that's going to keep me away from being proportional. So that is going to be no. And the third one is fine. It's a fraction, but it's KX, so this is going to be yes. In the graphs, this one does not go through the origin, so no. It is a line. This one is a line through the origin. This is through the origin, but not a line. No, for the same reason as number 4. Yes, fine, and no. This does not go through the origin. Let's take a look at a word problem. A cell phone company has towers that are in a proportional relationship, so they're telling you that yes, in fact, this is proportional. It is represented by the table below. So find the constant of proportionality and then solve the problem. You should be able to find the constant of proportionality here. Why don't you pause and do that? I got 48 towers to 1,000 customers. Be very careful here. Always read your charts. To 1,000 customers. And so to solve the last problem then, I would just set up a proportion. If there's 48 towers for 1,000, then how many customers would be served by 576 towers? So I just cross multiply and solve there. I get 12,000 customers. So you should be in good shape here. I would like you to work on your practice packet on the Think Graphically page, and we'll do some more work with this tomorrow. Have fun.